Check, check, check.
Okay. And I will note, since I actually submitted the description of who I am and what I do, I now work for a company called bakkenandbeck.com. It's based in Norway. We do all sorts of really fun applications. So if you're interested in learning more, please come find me after this. Before I start in earnest, I just wanted to say a big, big thanks to Daiki Matsudate for his help with the translation of these slides. As it says here in Japanese, Nihongo hanashimasen, which Daiki tells me means I do not speak Japanese. So I really, really, really appreciate all the help that he's given me in getting these translated. So let's begin. Raise your hand if before this conference you had heard of Kotlin. All right, looks like a lot of people. Keep your hand up if you work with someone who uses Kotlin. Still a fair number of people. Keep your hand up if you have worked with Kotlin yourself. Pretty much the same number of people. So there's definitely a few of you who have worked. You can put your hands down now. There's at least a few of you who are familiar with Kotlin. But to catch up those of you who are not familiar, Kotlin is a relatively new language which primarily runs on the Java virtual machine. And it was created by an independent builder of integrated development environments, which is called JetBrains. Now, as Swift developers, you probably know them as the people who build app code, although you might recognize them a little bit better from the old app code logo, which made it slightly clearer that app code was for use with Apple technologies than the current logo does. And JetBrains also makes a ton of other IDEs, including ReSharper, RubyMine, PyCharm, and PHPStorm. But all of these IDEs are descended from a single one, and it's called IntelliJ IDEA. This is JetBrains' Java IDE. IntelliJ's core is open source, and it has both paid and free editions. IntelliJ has done a lot to move Java development forward over the years. JetBrains believes in reusing code, so they've used IntelliJ as the basis for all of these other IDEs over the years. And since IntelliJ was built in Java for Java development, the JetBrains team developed a really deep knowledge of the advantages and the disadvantages of Java. So when they decided that they wanted to write their own programming language to take advantage of modern language features that Java could sometimes be a little bit slow to adopt, they decided that they wanted to write a new JVM language. Now, this sounds a little crazy, but it wasn't a totally insane idea. For years, languages like Clojure, Scala, and Groovy had already been built on top of the JVM. None of those languages had the features that JetBrains wanted, except for Scala, but at the time Kotlin was first built in 2010, Scala was known for its very, very, very slow compilation times. So they decided they wanted to build a language with all of the features they wanted and decent compile times, and they named it Kotlin. So that brings us to the question, what is Kotlin? Well, first I want to give a quick primer on what it's actually named after. It's an island near St. Petersburg, Russia. If your geography of this area is a little bit rusty, St. Petersburg is way up in Northern Europe. And it's not too far from either Helsinki, Finland, or Tallinn, Estonia. Now, the builders of Kotlin have said that they wanted to name it after an island, since Java itself was named after one of the main islands of Indonesia. So, as a room full of Swift and iOS developers, most of whom are not from St. Petersburg, you are probably asking yourselves, why on earth should I care? What does this have to do with me? And one big reason, if you work with a cross-platform team, is that it makes it much easier to communicate with your Android team about the code you're writing and share some basic thoughts, architecture, and logic. Because Kotlin has so many features which are similar to Swift, it suddenly becomes much easier to compare logic with your Android team than it was when you were working on Objective-C and they were working in Java. So how similar are these languages? Let's look at a few examples. First, how do you declare a constant string, a string which is assigned once and never changes? I think you're all very familiar with the Swift syntax for this. The good news is that other than the Kotlin equivalent of let being val, this is identical. Sweet. Now, how about declaring something that may or may not be there, but if it is, it will be an integer, an optional integer variable. Again, pretty familiar Swift syntax, and this time even better, the Kotlin equivalent of this is exactly identical. Like Swift, Kotlin brings native support for optionality to a major platform for creating mobile applications. Being able to have optional support was a particularly big win for Java developers, since it could be used to drastically reduce the number of null pointer exceptions that were experienced. So, you know how annoying it is when you have nil and you try to put it into an Objective-C array or dictionary and your application crashes? Imagine that happening with anything that's null. So where Objective-C, no ops on objects that aren't there, if it's not trying to stick something into an underlying C object, Java will throw an exception on any attempt to access a null pointer, and if it's not caught, it crashes your process. On Android, this crashes your entire app. So as much help as optionality has been in iOS, it's been a game changer for Android developers who had been writing in Java. Anyway, another way in which Kotlin is very, very similar to Swift is that it has both generics and functions as parameters. Java already had generics, so in this case, Kotlin is just maintaining an existing piece of functionality. But being able to pass functions as parameters to another function is new, unless you do some really interesting stuff. In Swift, you can use generics to say you want to apply a function to anything. And it can be used pretty easily by passing in both the thing you want to apply the function to and then the function itself into the same method. In Kotlin, generics are even more powerful because you're able to actually create an extension function, which is very similar to a Swift extension, on a generic type. So now you can call this on any type and apply any function designed to return any other type. This language feature allows the use of some of the same major functional collection methods, like map, filter, and reduce. Map and filter operators in Kotlin are exactly the same as they are in Swift. Map operator takes a collection of things and a transformational function, and then applies that transformational function to all of the things, and then returns the transformed objects. The filter operator checks all the things in the collection against a passed-in Boolean function, and then returns a collection of anything which passed true in that Boolean function. Reduce is somewhat similar, but there is a small, kind of annoying distinction where to get the exact same behavior in Kotlin as you have in Swift, you have to use a different function. So in Swift, when you reduce the contents of a collection, it applies whatever function is passed in by taking the accumulator, which is the start value, which is passed in as the first parameter of the reduce operator. Although I really, really, really hate this syntax for the function, it's also not really something which is available in Kotlin, so I'm going to make it ever so slightly clearer that the things being added are the first and second parameter which are being passed into the closure. And in this case, with an initial value of 0, adding each number to an accumulating value of the other numbers winds up being 6. But if you want to start somewhere other than 0 or a similarly empty value for whatever you're reducing, you can do that easily by changing the initial value. Here I changed it to 20, now the result is 26. So you're probably familiar with that part, but when you go to use reduce in Kotlin, it turns out that the reduce function has no initial value. It always starts with an empty of whatever value is expected to be returned. So a 0 value for integers in this case. So what do you do if you actually want to use the initial value parameter when you're working with Kotlin? Well, you have to use a different method. And that method is called fold. And you can see that in the end, it does exactly the same thing as Swift's reduce. Now, you may have noticed as you were looking at all of this code that Kotlin does a couple of things slightly differently when it comes to parameter placeholders for functions. In Swift, we use the $sign and the parameter index to indicate what parameter we are currently trying to access. In Kotlin, if you have a single parameter, you use the it keyword. And personally, this always makes me think of a horror movie based on a Stephen King book called It. And it's got a very, very creepy clown in it. And I often think of the clown trying to get me to use Kotlin. And just as there's only one very creepy clown in It, you can only use it to either represent a single parameter or a tuple of all of the parameters being passed into your function. Anything beyond that, and as you saw before, while you can use multiple $sign parameters, just building up as many dollars as you can with Swift, in Kotlin, excuse me, if you want to access more than a single or the entire set of parameters as a single blob, you actually have to break it into multiple variables. Now, there are a few of these little annoyances going back and forth between Kotlin and Swift code. But for the most part, the code looks very similar. And all of these similarities can lead to better communication between you and the people who are working on your Android application. You'll be able to look at their code, and despite some of the differences in view lifecycle and architecture, you'll be able to have an idea of what it's doing much faster. And the same goes for the Kotlin developers who are looking at your code. A fun side effect of this is that you become much more able to talk about common tooling and architecture ideas. In addition, no platform or language does everything right. But the more you learn about how other people tackle the same problems that you're facing, the easier it is to steal some of the best techniques and tools for your language. There's two things, one for each language, that I think the other language could benefit from stealing. The first is that Kotlin should totally steal Swift's guard syntax. There's currently a syntax for dealing with optionals that says, only do these things if this actually exists. And it's this. It's using let instead of val to unwrap. So I guess the Kotlin designers wanted to make a distinction between the operator and the keyword. Maybe they just thought making it .val would be way too obvious. Personally, I find this syntax to be far too similar to checking nullability and then force unwrapping, you'll note with 2 exclamation points instead of 1, if you find the object to be non-null. I really do agree that the if it fails, bail out model of Swift is easier to read. So I would be really, really happy to see something like this come to Kotlin. Now, a really nice thing in Kotlin, which I think Swift should steal, is the apply function. Right now in Swift, if you have a single instance of something, especially if it's a singleton, which you want to do multiple things with, you have to either access that singleton in full for every single action, or pull it out into a single variable and then repeatedly access that variable. What the apply function in Kotlin, as I propose it be stolen by Swift, would allow you to do is set values in a single closure on a given type. It's a little bit of an adjustment starting to read things this way. Once you make that adjustment, it becomes so much clearer when you're trying to work with multiple methods being called on the same instance. But what if this cell sounds really good? You really hate Java. Good news, you have a few options. So Kotlin already has functionality to allow it to be cross-compiled into JavaScript. The idea is fairly similar to TypeScript in that you want type safety without having to necessarily give up the whole wide array of libraries you can take advantage of in JavaScript. But the thing that may be of more interest to you as Swift developers is something called Kotlin Native. Kotlin Native is an experimental program currently in early access preview. This is the functional equivalent of an alpha, but it sounds a lot cooler. Kotlin Native allows Kotlin code to be compiled using LLVM into machine code. And if that sounds familiar, that's because LLVM is the same compiler used by Swift. And it was built as the graduate thesis of some dude named Chris Lattner, who you may know better as the inventor of Swift. Fun fact, LLVM was not Chris Lattner's doctoral thesis, it was his master's thesis. Every time I am reminded of that fact, I feel about 5 years older. Anyway, what it means is that LLVM is being used to compile Kotlin. And that compiled code can run directly on various processor architectures without the need for a virtual machine. And what that means is that theoretically, code compiled from Kotlin can be optimized for particular architectures in ways that are not possible with the JVM. Because a ton of architectures are supported out of the box by LLVM, that means that Kotlin Native can also support a lot out of the box. While they don't support everything that LLVM supports, the list of supported platforms for what is essentially an experimental alpha release is pretty impressive. And it points to the long-term ambition of Kotlin Native. Clearly, JetBrains wants to turn Kotlin into a language which allows for shared modules across many different types of architecture. So to facilitate doing all this, JetBrains built a plugin and a build system for IntelliJ and Android Studio, which helps abstract away a lot of the inconveniences of making it all work. They named it Conan, with a K, just like Kotlin, because they are really, really, really into branding. When you go through some of the setup process for building some of the binaries that you need to run, you will get a pretty good idea that this is something that is still in a very experimental change phase and subject to a large amount of change. When you're working with a fairly new tool, you usually want to look at the documentation on how to use it. Unfortunately, Kotlin Native's documentation is sometimes non-existent, sometimes it's well updated, and sometimes it's super outdated. It's often hard to tell without a lot of trial and error which one of these is the case for any given subset of code. I can tell you that the setting up from scratch portion is very poorly documented at the moment, since there are a large number of pieces of the puzzle that you basically have to find through trial and error. I am still very much in the error part of this process. So please bear in mind that this is a technology with a ton of potential, but it is not quite ready for use in production unless you're really willing to take a risk. But one thing Kotlin Native means is that despite everything I said earlier about Kotlin being born on the Java virtual machine, now you can choose whether you want to use Kotlin with or without Java. I suspect if most of you had the choice, you would choose without. So if all of this has gotten you interested in working with Kotlin, there are a few places that you can get started. The first is an online sandbox called trykotlinlang.org. What this does is that it allows you to create very simple Kotlin code, and then it allows you to mess around with it a bit and see how your changes affect the output. Think of it like a playground, but on the web. If you have managed to commit enough to download either IntelliJ or Android Studio, both of which at least have a free version, you can try the EDU Tools plugin. You install it through your IDE, either, again, IntelliJ or Android Studio. It gets special treatment because it's created and maintained by JetBrains. You can search specifically for JetBrains plugins. Once it's installed, you can download a course called Kotlin Cones, which gives you some challenges you can use to teach yourself Kotlin. It's great because it's baked right into your IDE, so you don't have to worry about the internet being flaky the way you do with the website. Having the ability to just randomly mess around with this stuff is really fun, and it encourages you to explore and try new things. And with that, we've come to the obligatory summary slide. I have a little bit less space than usual for this, since the translations take up a bit of space, so I'll keep this fairly simple. Kotlin allows you to be friendlier with your Android team, sharing your joys and your triumphs, along with your frustration and tribulations. And while Kotlin Native is really cool, it's not quite ready to be used in the real world. I am really, really interested to see what it says about the future of Kotlin as a language, which is potentially fully independent of the JVM. In the end, my advice really boils down to one thing: give Kotlin a try. Though, since this is a Swift conference, I must pay homage to Steve Jobs and announce one more thing. If you are interested in learning about Kotlin, you will be happy to hear that leading iOS site, RayWenderlich.com, has got some stuff brewing. I have been lucky enough to be a tech editor on one book, and I'm writing several chapters of another book. Both are related to Kotlin. Both are coming soon-ish. Keep an eye out for more announcements in the next month or two. And with that, ohayou gozaimasu.